Hello everyone, I am Prakhyath, Assistant Professor, Department of Mechanical Engineering, AJIET Mangalore. Today I am going to discuss about Module 3 of Fluid Mechanics, that is Class 4, Continued Portion of Fluid Dynamics. In this video, I am going to discuss about problems on inclined venturimeter. So, ninth problem, in a vertical pipe conveying oil of specific gravity 0.8, two pressure gauges have been installed at A and B, where the diameters are 16 cm and 8 cm respectively. A is 2 meters above B. The pressure gauge readings have shown that the pressure at B is greater than at A by 0.981 Newton per centimeter square. Neglecting all losses, calculate the flow rate. If the gauges at A and B are replaced by tubes filled with the same liquid and connected to a U-tube containing mercury, calculate the difference of level of mercury in the two limbs of the U-tube. So there is a vertical pipe. This problem is related to vertical pipe conveying oil of specific gravity 0.8. That is flowing fluid has specific gravity 0.8. Two pressure gauges have been installed at A and B. So what is the function of pressure gauge? It is used to measure the pressure at inlet of the pipe as well as at throat. So where the diameters are 16 cm and 8 cm respectively. So dA equal to 16 cm, dB equal to 8 cm respectively. A is 2 meters above B. So that is ZA minus ZB equal to 2 meter. The pressure gauge readings have shown that pressure at B is greater than at A by 0.981 Newton per centimeter square. Pressure at B, so that is PB, that is equal to 0.981 plus PA. So pressure at B is greater than 0.981 compared to A. So PA plus 0.981 Newton per centimeter square. Neglecting all losses, calculate the flow rate, that is volumetric flow rate or discharge. You are supposed to find Q value. If the gauges at A and B are replaced by tubes filled with same liquid and connected to a U-tube containing mercury, calculate the difference of level of mercury in the two limbs of U-tube. So the pressure gauges, if we replace the pressure gauges by a U-tube manometer, so what is the reading of U-tube manometer, or that is the difference of level of mercury in the two limbs of U-tube, that is X value you are supposed to find here. So there's a second case. First case, it is related to the venturimeter having pressure gauge. Second case, the venturimeter fitted with the U-tube manometer. So solution, specific gravity of oil, that SO equal to 0.8, that is of flowing fluid, that is 0.8. Now specific gravity equal to density of given fluid to density of standard fluid. Density of standard fluid is here water, that is 1000 kg per meter cube. So we can easily get density of oil, that is rho equal to 0.8 into 1000. So that is equal to 800 kg per meter cube. So this is the diagram. So it is given in problem that A being higher at a level of 2 meter from B. So larger diameter, A has diameter 16 centimeter. So larger diameter should be kept at a higher level compared to the smaller level, smaller diameter, that is PB. So ZA minus ZB, that is 2 meter. Assume that the section B or point B is passing through datum or reference. So that ZB value equal to 0. So ZA minus ZB equal to 2 or ZA minus 0, that is equal to 2. So ZA value becomes 2 meter. So dA equal to 16 centimeter, dB equal to 8 centimeter. And there are two pressure gauges to measure inlet pressure and throat pressure at A and B respectively. So given data, diameter at A, dA equal to 16 centimeter, so that is equal to 0.16 meter. 16 by 100 to convert from centimeter to meter, so it becomes 0.16 meter. Area at A, that is AA equal to pi by 4 dA square. So pi by 4 into 0.16 square, so that is equal to 0.0201 meter square. Diameter at B or diameter at throat, dB equal to 8 centimeter, so that is equal to 8 divided by 100, that is equal to 0.08 meter. Area at B, AB equal to pi by 4 dB square. So that is equal to pi by 4 into 0.08 square. So that is equal to 0.005026 meter square. Difference of pressure. So it is given in problem, pressure at B is greater than pressure at A by 0.981. So PB equal to PA plus 0.981. So PB minus PA, there is a difference of pressure becomes 0.981 Newton per centimeter square. Now you are supposed to convert from Newton per centimeter square to Newton per meter square just by multiplying 10 to the power 4, because centimeter equal to 10 to the power minus 2 meter. So 10 centimeter square 10 to the power minus 2 whole square. So 10 to the power minus 4. So that goes to numerator and becomes 10 to the power 4. So 0.981 into 10 to the power 4, that is PB minus PA equal to 0.981 into 10 to the power 4 Newton per meter square. Now applying Bernoulli's equation at A and B and taking reference line passing through section B. That's what I told in problem in question. Assume the section B is passing through datum or reference, so that ZB value equal to 0. So PA divided by rho G plus VS square divided by 2G plus ZA equal to PB divided by rho G plus VB square divided by 2G plus ZB. Just rearrange PA by rho G minus PB by rho G plus ZA minus ZB equal to VB square divided by 2G minus VA square divided by 2G. Now what is PA divided by rho G minus PB divided by rho G equal to? So we have PB minus PA. So denominator it is common, rho G. So PA minus PB divided by rho G plus ZA minus ZB equal to VB square divided by 2G minus VA square divided by 2G. So PA minus PB minus PA is 0.981 into 10 to the power 4. So PA minus PB becomes minus 0.981 into 10 to the power 4. So that is PB minus PA divided by rho G plus 2.0 minus 0, that is equal to VB square divided by 2G minus VA square divided by 2G. So minus 1.25 plus 2 minus 0 equal to VB square divided by 2G minus VA square divided by 2G. So PA minus PB, that is minus 125, because PB minus PA is 0.981 into 10 to the power 4. So just divide by 1800 into 9.81. So 9.81, 0.981 minus 0.981 into 10 to the power 4 divided by 800 into 9.81. So that is minus 125 plus 2.0 minus 0 equal to VB square divided by 2G minus VA square divided by 2G. So minus 1.25 plus 2, that is 0.75, that is equal to VB square divided by 2G minus VA square divided by 2G. Take it as expression 1. Now applying continuity equation at A and B, we get AA into VA equal to AB into VB. So from that we can get expression for VB equal to AA into VA divided by AB. AA value is 0.0201, AB value is 0.005026. Just substitute VB equal to 0.0201 into VA divided by 0.005026. So that is equal to 4 times of VA or 4 VA. VB equal to 4 VA. Now substituting the value of VB in equation 1, we get 0.75 equal to, in place of VB, 4 VA whole square. So 4 VA whole square divided by 2G minus VA square divided by 2G. So 4 VA whole square, that becomes 16 VA square divided by 2G minus VA square divided by 2G. So that is equal to 15 VA square divided by 2G. 16 minus 1, that is 15. 15 VA square divided by 2G. So now VA square equal to, just cross multiply or rearrange, equal to 0.75 into 2 into 9.81 divided by 15. So VA equal to square root of 0.75 into 2 into 9.81 divided by 15. So VA value is 0.99 meter per second. This is a velocity at section AA, that is equal to 0.99 meter per second. Therefore rate of flow Q equal to AA into VA, so that is equal to 0.0201 into 0.99. AA value is 0.0201, VA value is 0.99. So that is equal to 0.01989 meter cube per second. You can go with Q equal to AB into VB, but for that you need VB value. So you have to calculate from VA, that is VB equal to 4 times of VA. Then by substituting AB and VB value, you can get value of Q as well. So it is easy because we have VA value and AA value, so we can directly get rate of flow. So that is equal to 0.01989 meter cube per second as the rate of discharge. Now second case, difference of level of mercury in the U-tube. So reference of level of mercury in the U-tube. Pressure gauges are replaced by a U-tube. So AA section and BB section, that remains as it is. Instead of pressure gauges, we are going to connect one U-tube. Now we are supposed to find the difference of mercury level in the U-tube, that is X, you can see in that diagram. So then H equal to PA divided by rho G plus ZA minus PB divided by rho G plus ZB equal to x into sh divided by so minus 1. So PA divided by rho g plus ZA. So ZA and ZB value you are supposed to find. For horizontal venturimeter, it is P1 divided by rho g minus P2 divided by rho g equal to H. Now here it is inclined or vertical venturimeter. Here it is one vertical venturimeter here. So ZA and ZB value, those are not equal to 0 here. So you are supposed to consider ZA and ZB. So that is case 3. PA by rho g plus ZA minus PB divided by rho g plus ZB equal to x into SH divided by SO minus 1. Why case 3? Because specific gravity of manometric fluid is greater than specific gravity of flowing fluid. So that is 13.6 is greater than 0.8. So just rearrange PA minus PB divided by rho g plus ZA minus ZB equal to x into SH divided by SO minus 1. So PA minus PB minus PA equal to 0.981 into 10 to the power 4. So PA minus PB, that is minus 0.981 into 10 to the power 4 divided by rho value is, just remember, it is not 1000 here. Rho of flowing fluid, that is 800 into 9.81 plus ZA minus ZB, that is 2. ZB value is 0 because atom is passing through the section B. So minus 1.25 plus 2 minus 0 equal to x into SH value is 13.6, SO value is 0.8. So 13.6 divided by 0.8 minus 1. So 0.75 equal to 16x, or x equal to 0.04687 meter. So now 1 meter equal to 100 centimeter. You can convert to centimeter as well here. So for 0.04687 into 100. So that is equal to 4.687 centimeter. So there is a difference of manometric fluid or mercury in U-tube. Last problem. In a 100 mm diameter horizontal pipe, a venturimeter of 0.5 contraction ratio has been fixed. The head of water on the meter when there is no flow is 3 meter gauge. Find the rate of flow for which the throat pressure will be 2 meters of water absolute. The coefficient of meter is 0.97. Take atmospheric pressure head equal to 10.3 meter of water. So there is a horizontal pipe. This problem is related to horizontal venturimeter. Horizontal pipe with the inlet diameter of 100 mm. And contraction ratio of 0.5 has been fixed. So what is contraction ratio? Contraction means lesser divided by smaller value divided by larger value, that is a contraction. Smaller diameter divided by larger diameter, that is equal to contraction ratio. What is the smaller diameter here? Throat diameter is always lower, smaller value. D2 by D1 equal to 0.5. There is a contraction ratio. Now the head of water on the meter when there is no flow is 3 meter gauge. I'll discuss about thing later. Find the rate of flow, that is Q value, for which throat pressure will be 2 meters of water absolute. So throat pressure, it is given in terms of water head. So P2 divided by rho g equal to 2 meter absolute. So absolute pressure, it is a total pressure. But what about other pressure? The head of water on the meter when there is no flow. That means if this is P2 by rho g, then it should be P1 divided by rho g. So P1 divided by rho g equal to 3 meter gauge. So it is a gauge pressure. So you have to get the P2 by rho g, it is given in absolute pressure. So you cannot have different unit for two pressures. So our pressure head. So you have to get in terms of same unit. So absolute pressure. So absolute, for getting a pressure in absolute pressure, the absolute atmospheric pressure head it is given. That is 10.3 meter of water. So just add 10.3 to P1 divided by rho g. So that you should get value of P1 divided by rho g in absolute. So 3 plus 10.3, that is equal to 13.3 meter of water. So you have to remember here because they have given here atmospheric pressure head. So just add to gauge pressure so that you should get value in absolute pressure, absolute head. So solution, diameter of pipe D1 equal to 100 mm, that is equal to 0.1 meter. A1 equal to pi by 4 D1 square. So that is equal to pi by 4 into 0.10 square. So that is equal to 0.007854 meter square. Contraction ratio, that is smaller diameter divided by larger diameter, D2 by D1 equal to 0.5. Now we have value of D1, so we can calculate diameter at throat. So diameter at throat D2 equal to 0.5 into D1, so that is equal to D1 value is 0.1. So that is equal to 0.5 into 0.1. So value of D2 or throat diameter, that is equal to 0.05 meter. So we have a diameter now, so that we can calculate easily a cross-sectional area. So A2 equal to pi by 4 D2 square. So that is equal to pi by 4 into 0.005 square. So that is equal to 0.0019635 meter square. That's the A2. Next, head of water for no flow, that is P1 by rho g. I already explained about this thing. That is equal to 3 meter gauge. Now from gauge to absolute, you have to add atmospheric pressure head. So 3 plus 10.3, atmospheric pressure head it is given as 10.3. So 3 plus 10.3, that is equal to 13.3 meter absolute. Throat pressure head P2 divided by rho g, that is equal to 2 meter of water absolute. It is already given in absolute pressure. No need to convert anything here. 2 meter of water absolute. Therefore, difference of pressure head H equal to P1 divided by rho g minus P2 divided by rho g. Why there is no Z1 and Z2? Because this is a horizontal venturimeter. Z1 equal to Z2, that is equal to Z1 minus Z2, that becomes 0. So P1 divided by rho g minus P2 divided by rho g. We have P1 divided by rho g and P2 divided by rho g values. So 13.3 minus 2, so that is equal to 11.3 meter. So that is equal to H. Now we have H value, A1, A2, CD value it is given in problem. So we can easily calculate rate of discharge. So Q equal to CD into A1, A2, square root of 2GH divided by square root of A1 square minus A2 square. So that is equal to 0.97 into 0.007854 into 0.0019635 into square root of 2 into 9.81 into 11.3 divided by square root of 0.007854 square minus 0.0019635 square. So that is equal to, upon simplification we get Q equal to 0.0293068 meter cube per second. So there's a discharge. So you can convert to liter per second. It is not asked in question. So you can just do that. So 0.0293068 divided by 10 to the power minus 3, that is equal to 29.3068 liter per second. There's a value of discharge, rate of discharge or rate of flow. So that's the end of this solution. So in next video I am going to discuss about some more problems on incline venturimeter and orifice meter pitot tube. So thank you.